Okay, in this problem, we are going to answer these questions. What is the probability that a baby will have a length of 20.4 inches or more? So as we read the problem description for 6.29, we see that the average length of a newborn baby is 19.5 inches. So that will be our mean, 19.5, and the standard deviation is 0.9. And it says that they are approximately normal. Okay, it says include an appropriately labeled and shaded normal curve for each part. So for part A, we're going to draw a normal curve. In the center, we put 19.5. The number we're interested in is 20.4, which is larger than 19.5. So I'm going to put 20.4 over here. And we want to know 20.4 or more. So we are interested in the area to the right. This is the area that we want. And we want to know what probability or what percentage of that is shaded. So our first step with all of these normal problems is to find the z-score. And so our z-score is going to take the value that we have, 20.4 minus 19.5 divided by 0.9, okay? So when I plug this into our calculator, 20.4 minus 19.5 gives me, it's doing this mode, let me just switch really quickly. Okay, 20.4 minus 19.5 is going to be 9/10, and if I divide that by 0.9, we see I have a z-score of +1. And so we want to know what is the probability that the baby will have a length of 20.4 inches or more. So here my z-score is 1.00, and I'm going to go to my z-table and I'm going to look up a z-score of 1.00, and the number I find is 0.8413. So area to the left, that's what the table always gives us. Area to the left of z equals 1 is 0.8413. That's going to be the area to the left of 20.4. But what I want is the area to the right, because it says 20.4 inches or more. So this area is going to be 1 minus 0.8413. And so I can do 1 minus 0.8413, and I get 0.1587. And that is the answer to part A, because we are asking for the area to the right of 20.4. For part B, it says, what is the probability that a baby will have a length of 21.4 inches or more? Okay, so here it's something very similar. I'm centered at mu 19.5, and I'm going further to the right at 21.4. And I want to know how much is going to be shaded in over here, because I'm asking 21.4 or more. So z, we're going to start off by finding our z-score, is going to be 21.4 minus the mean of 19.5 divided by our standard deviation of 0.9. 21.4 minus 19.5 gives me 1.9, and I'm going to divide that by the standard deviation of 0.9. I get a z-score of 2.11. Okay, we have to round our z-scores to the 100th of a decimal place. I'm going to go to the table and I'm going to look up the area to the left. Area to the left of z equal to 2.11. So we're going to go to the table and we're going to look up z equal to 2.11. Is going to, the second column is 0.01, so 2.11 is 0.9826. Again, that's the area to the left. And what I want is the area to the right. So the area to the right is 1 minus 0.9826. I'm going to calculate that right here. And I get 0.0174. So the area to the right is 0.0174, and that is the answer to this problem. Let's switch it up for the last problem. It says what's the probability that a baby will be between 18 and 21 inches in length? Okay, so in this case, we're still centered at 19.5, but 18 inches is smaller than 19.5, and 21 inches is larger than 19.5. And I want to know how much is in between. And we're going to solve this, find this area, by first finding the area to the left of 21, and take all of this area. And then I'm going to find the area to the left of 18. And I'm going to subtract this off from over here. And so if I subtract this piece, which is this piece down here, if I subtract that, I will be left with the area in the middle, which is what I want. So let's find the z-score for 21. So 21 minus 19.5 divided by 0.9 is 1.67. I get a z-score of 1.67. We're going to find the z-score for 18. 18 minus 19.5 over 0.9. It's going to be negative 1.67, but we'll punch it out. 18 minus 19.5 gives me negative 1.5. I divide that by 0.9, and I get negative 1.67. Okay, so I'm going to find the area to the left of z equal to positive 1.67, and I'm going to find the area to the left of z equal to negative 1.67. I'm going to do the same thing using the table. So first, positive 1.67. 1.6 is this row right here. The column 0.07 gives me the area to the left is 0.9525. I'm going to look up on the negative side of the table. Negative 1.67. Negative 1.6, column 0.07 gives me 0.0475. So what I'm going to do is I'm going to take the difference between those two areas, and that will give me the area in between. So area between is equal to 0.9525 minus 0.0475. And I'm going to punch that in here. And I'm given 0.905 as the area in between. And that is my answer to part C.